In this video, we're going to do an extension question on coordinate geometry. We're told the line x minus 2y plus 4 equals 0 cuts the x-axis at A and the y-axis at B. Line L is the perpendicular bisector of the line segment AB and cuts the x-axis at C. We're asked to find the area of triangle ABC. Let's start off by finding A and B. What I'm going to do is a quick sketch of a set of coordinate axes. So what we're going to have then is the x-axis and the y-axis. If we consider now A, this is where the line x minus 2y plus 4 equals 0 crosses the x-axis. So at A, we can say y will be equal to 0. Therefore, what we're going to have is x plus 4 will be equal to 0, and that gives me that x will be equal to minus 4. So what I'm going to do is put this point just here, and we're going to have now A, which is going to be minus 4, 0. Let's now look at B. If we have B, that's where the line crosses the y-axis. So we can say that x will be equal to 0. So we're going to have minus 2y plus 4 is equal to 0. Rearranging, 2y will be equal to 4 and y will be equal to 2. So we're going to have this point just here, and that will be just there. That is going to be B, and that will be 0, 2. So what we have then is the line that we've got is x minus 2y plus 4 is equal to 0, and then we have now the line segment AB. So if we pop this on, we'll end up with something looking like so. So all I'm going to do is label this up. This is going to be A, and this is going to be B. We want the perpendicular bisector. For the perpendicular bisector, we need the gradient of a line perpendicular to x minus 2y plus 4 equals 0, and we need the midpoint of this line. So let's go ahead now and find the midpoint of this line. So all I'm going to do is add the x's together. So I'll just say now that this is the midpoint. So we're going to add the x's together and divide by 2. So that'll be minus 4 plus 0 divided by 2. And we're going to add the y's together, which will be 0 plus 2 divided by 2. So we end up now with minus 2, 1. So this is the midpoint just here, and that's going to be minus 2, 1. We now need the gradient. If we rearrange this into the form of y is equal to mx plus c, we start off with x minus 2y plus 4 is equal to 0. So we can say that 2y will be equal to x plus 4. Dividing both sides by the 2, we've got 1/2 x plus 2. We can see that the gradient of the original line x minus 2y plus 4 equals 0 is 1/2. I'm going to state now that m1 is equal to 1/2. Therefore, m2, the gradient of the perpendicular, will be equal to minus 2. We take the negative reciprocal, and we can state as m1 multiplied by m2 will be equal to minus 1 if perpendicular. So now we've got the equation of a line to find from the point that it goes through and a gradient. So what we're going to be looking at is something like so. So we're going to have a line at right angles to the original, and then we're going to cross now at this point just here. So let's go ahead now and find the equation of this line. We have the point that it goes through, which is going to be minus 2, 1, and we have a gradient of a line. We can see that the gradient of a line is also going to be minus 2. So we can use y minus y1 is equal to m the gradient x minus x1, or we could use y is equal to mx plus c. So subbing in, y minus 1 is equal to minus 2 multiplied by x minus minus 2, which will be x plus 2. If we just tidy this up, we can see that this is going to be y is equal to minus 2x. We're going to have minus 4 plus 1, and that's going to give me now minus 3. We want to know where this crosses the x-axis. This is going to be the point C. So that's the point C just here. So all we need to do is set y equal to 0. So we can say now for C, y will be equal to 0. So from this, we can see now that we're going to add 3 to both sides. So we'll start with 0 is equal to minus 2x minus 3. So 3 is equal to minus 2x, and that gives us minus 3 over 2, or minus 1.5 is equal to x. So we have this point just here. So we've got minus 3 over 2, 0. I want to find now the area of a triangle ABC. So this is our point C just here. So if we sketch this up, and I'll just draw a quick picture, what we're going to have is something that looks like so. So we're going to come up here, down here, and then to this point here. So all we need to do is 1/2 base times by height. So if we now think about the base, we've got the base, and that's AC, and then we're going to look at the perpendicular height. So all I'm going to do is just a quick sketch just here. So if I look now at the base, we've got the base, and we've got now -4 to -3/2. So that's going to give me now 2.5, or if you like, 5/2. So we've got 5/2. That's the distance between A and C. We're now going to look at the perpendicular height. The perpendicular height is simply now the y coordinate here, and that's going to be 2. So if we put that on, we've got a perpendicular height, and that is going to be 2. So just popping this on, let's put that there, that's going to be 2, and this is going to be B. So we've got the dimensions that we need, and we simply need to use the area of a triangle. The area of a triangle is given as 1/2 base times by height. So we can say that the area will be 1/2 multiplied now by the base, which is 5/2, multiplied by the height, which is going to be 2. So we can see that the area is going to be 5/2, and that will be units squared. So the area of triangle ABC is 5/2 units squared.